All right. So we have actually talked a little bit about resonance. We haven't made a big deal about it, but basically, if you get to the point when you need to make a double bond and you have multiple double bonds that you can make, that's resonance. Now, what the scientific society says is that in reality, versus any one of these actually being formed, it's kind of a combination of all three. Imagine a game of hot potato where instead of a potato, you have electrons. And basically, these atoms are shifting these electrons around to wherever they're needed. And whenever I say wherever they're needed, basically, if you get some type of positive type of charge somewhere, the electrons are going to be attracted to that area. Keep in mind, these when we draw these bonds, these are not stiff sticks. These are electrons that are shared in what we call orbitals. And if these are moving constantly, they're just being kind of shared between these guys. They're not anything other than just a sharing of electrons. And if these electrons need to jump over here for a second, they will. If they need to jump up here for a second, they will. This resonance, these electrons are just available to move around a little bit more freely around the molecule. So take a look. That's how you actually spell resonance, not like the way I did on the other page. But they call it the shifty bond. So if we were to draw SO2, we have 6 plus 12, which is 18 electrons. S is in the middle because it's the most unique. We're going to put oxygens on each side of it. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We are 2 over. We are 2 over of our 18 amount. So that means we need a double bond. The question is, we could put it here or we could put it here. That denotes that we have resonance going on. So if I put it here, remember, I take away a pair of electrons from both atoms involved. The problem is if I could put it here as well, I need to show that I could put it here as well. Oops. Now here's a cool thing. What is the actual shape of this? Well, remember, we look at the number of atoms bonded to the S. So this is 1 oxygen, 2 oxygen. So this is 2 bonded atoms. And we look above, we have 1 unshared pair, or 1 lone pair. That shape then is angular or bent. The angle for that is 120. In both situations. Last thing is isomers. So isomers, it is sometimes possible for things to have the same formula, but 2 different ways to draw the Lewis structure. So if we take a look, C2H6O, we can draw 2 different structures for this. This is the easier of the 2 that we would probably draw first. The 2 C's next to each other and the O next to each other. Again, with things like C's, like in a chain like this, we don't necessarily have a central atom. It's just like a delocalized centralness. So we have CC, and each C gets 4 bonds. There's only 1 O, so it's going to be bonded to one of the C's in this case, and then plenty of H's to go around. Here, this is what we call an alcohol. Here, this is what we call an ether. If we take a look, Sometimes the O, even though, I mean, you might look at this as a central atom more than less, than it's not central, it's more of a bridging atom in this case. If we take a look here, this is an ether. It is breaking the bridge between the two C's. This is ethyl alcohol. If we were to take a look at this, I need more sticks. Oh, maybe not. Yeah, I do. Give me 1 second. So this is the only alcohol that your body has the ability to break down. And it looks like this. Looks like a dog, kind of. This is ethyl alcohol. Now imagine if I take this and, you know, I give it to like my niece or nephew or whatnot, and they sit there and go, oh, I want to play with this thing. And they just take it and rearrange it. They haven't lost any pieces or done anything else. They just rearrange it. This is an isomer. All I've done is moved some parts around. I haven't taken away any carbons or hydrogens or bonds. I just moved some parts around. Now that's ether. Now, the importance is that these are two very different compounds. This is alcohol. This is ethyl alcohol. That's what you find in beer, wine, and spirits. This is ether. This was the first anesthesia. So this one, let's take the Civil War, for example. One of the worst wars for wounded individuals that with cannon fire and stuff like this, you could get a limb crushed and it needed to be amputated. It was thought that maybe you could get a person drunk and then cut off their leg or their arm. Unfortunately, this did not happen with successfulness many, many times. A drunk person could still die of shock and stuff like that. But ether, same number of carbons, same number of hydrogens, same number of oxygens, different arrangement. Ether would basically slow the oxygen to the brain and put somebody in what we call an anesthetized position. Basically, then they are asleep and they would not feel the pain or shock from having a limb cut off. And under the ether, you could then cut that off and cauterize it, and you would see a recovery in the person. So these two are what we call isomers. For example, if we take a look, let's take butane, C4H10. So what all kinds of combinations can we make with butane? Well, we can put them all in a straight row. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put the hydrogens all around it. What's another thing? Well, I could take this carbon and I could move it so that's attached to this carbon. So we have 3 carbons and then 1 carbon coming off. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These two things are isomers of each other. The same number of carbons, C4 and H10, just rearranged. So if we take a look at this, H2O2, we don't want to keep in mind there's no unique atom. Hydrogen cannot go in the center because it can only make 1 bond. So if we want to put this thing together, the oxygens are going to be together. If we want to make it symmetrical, one oxygen has a hydrogen and the other oxygen has a hydrogen. So if we take a look, we have two electrons from the hydrogens plus 12 electrons from the oxygens for a total of 14. Here we have 2, 4, 6. Hydrogen does not get any lone pairs. 2, 4, 6, 8, 10, 12, 14. 3 carbons, we can put those in what we call a chain, and then we can put the hydrogens around them. C4H10, well, from previous exercise, you can take a look at the isomers of that. And then last but not least, the ion thing that we talked about at the end of Thursday's discussion. Remember the ion, if we take a look here, we have 7 electrons plus 4 times 6. 4 times 6 is 24. So that's a total of 31. But the negative here means that we add 1. So that's 32. We have ClO4. Don't forget, we need to put brackets around it and that negative charge. We have 4 oxygens. 2, 4, 6, 8. We need to get 32 electrons. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So for this evening, I'd like for you to do the rest of this exercise, number 5. And I'd like for you to do number 3. And if you've not finished up this back one, we're going to talk about that tomorrow as well. And then we'll talk about polarity. Please, before you leave today, let me get the attendance real quick. How do I do this? Participants. So after I say your name, you may leave, but let me get the attendance real quick.